And we are live. What is up, everyone? Welcome back to my live stream. My name is Tyler Ramsbey, and in this stream, at least the first part of it, we're going to dive into the brand new TryHackMe room, all about container vulnerabilities. It is a subscriber-only room, so if you're not a THM subscriber, you can't do it yourself, but hey, you can live vicariously through me. It was a room that was released just a few days ago, and I've been wanting to dive into it, have read some good things about it on Discord, but wanted to wait until I did it live on stream. So as usual, have not looked at the room at all ahead of time besides opening up and starting the machine, and we will dive into it. Don't know how long it will take me, but if we finish up early, maybe we'll dive into something else and continue our hacking. And I will, if you see me keep looking off camera, it's because I also have to keep my eye on my cat. My cat had like some minor surgery on his, kind of by his paw, and he's not supposed to lick it. And they gave us like a cone to put on my cat's head. But yo, my cat's like this. I think he weighs 17 pounds if I remember from the vet clinic. He's not fat. The thing's just like big. There's no way I can get this stupid cone on his head. So instead, I'm just like watching him and yelling at him when he licks his paw. Although he might be going upstairs now. So if you see me yell off screen, I don't have ghosts in my house. I'm just yelling at my cat. But I want to say hello to everybody over in the chat. Just a reminder, I'm live streaming to 3 different platforms here. Welcome to join on whatever platform works best for you. I am live on LinkedIn, I am live on Twitch, and I am live on YouTube. So join whichever one works best for you. All of them work for me, and we will dive on into this. I'm going to share my screen. We are doing Parrot again. Parrot just runs better as a VM on this specific computer. But y'all, I fixed Nano. Let me show this to you guys. Anyone who watched my last stream, you saw me almost lose my mind because my Nano doesn't work, or it wasn't working. Like if I try to save stuff, everything bugged out. Watch this. Everybody watching? Please subscribe. We'll type in my YouTube link. All right. Oh no. Oh no, I said it was fixed. It's not fixed. No. No. It's the backspace that's broken. So I was thinking it was a save button. Look, I can't even type. I was thinking it was a save button. It's the backspace. So when I hit backspace, it says unbound key A. Why do you think it does that? Isn't that weird? Watch, I'm gonna hit the backspace. All right, what if I hit delete? That doesn't do anything. So it pulls up the help text. Oh, wow. You know, we're going to, before, our first challenge of the stream, why does Nano break when I hit backspace? I fully reinstalled Nano thinking that would fix it. We're going to see if we can figure this out. Otherwise, I'll just dive into the room. Because you don't want to watch me try to fix my Nano. Okay, nope, I'm not fixing it. Weird. I could have swore I fixed it. I can't believe I started the stream saying I'm going to show you guys how Nano's fixed, only for Nano still to be broken. So I just need to remember to do Pluma and everything will work. If we even need it. I have no idea what we need for this room. That's frustrating though. Oh well. Let's, fixing Nano would still be interesting. Honestly, that's probably like an insane machine on Hack the Box. I'm not feeling up to it. I don't think it's a common issue. First time I've ever had it happen only on this specific Parrot VM. Doesn't happen on my other Parrot VMs, like on my other computer. Doesn't happen in Kali. Doesn't happen in the attack box. So it's just something weird that I did on here. You know what? Actually, I'm curious. What if we do? What if I do a different terminal? Oh, it just affects the Q terminal. Isn't that weird? So it's something with this. Okay, hold up. Now I am curious. Whoops. Parrot is actually what it is. Where's the config for the Q terminal at? Jeez, I don't even know. Would I have to go in here? I bet it has something to do with things here. But I'm not even sure how to fix it. Oh well. There. Although, does this have... Can I rename these? See, this is why I like QTerminal. I like to name my tabs. I can't even rename this tab. And it just shows the output of the last command. On QTerminal... What? On QTerminal, my shortcuts are Control-Shift-T. And if I want to rename it, it's Alt-Shift-S, and I can rename it. Because I like to name my tabs. We're just going to stick with QTerminal and my weird nano behavior. But hey, I kind of solved it. It's limited to something with my QTerminal config. I'll figure it out later. But let's dive into this machine. Trying to figure out what my cat is. It's at the top of the steps. All right. Let's dive into this machine and see what we can learn. This room will demonstrate some of the common vulnerabilities found in Docker containers and how an attacker can abuse these to escape. Sweet. So what are our learning objectives? So some of the vulnerabilities that can exist in a Docker container, what we can gain from exploiting these vulnerabilities, why they exist, and how to search for them within a Docker container. I think I've already done this room. And I have. Beautiful. Important context. This room focuses on exploiting the Docker daemon itself, which often relies on having elevated permissions within the container, which it does. In other words, this room assumes that you've already managed to become root, and you'll often see this in CTFs. When you get into a CTF and you're a low-level user in a Docker container, often you need a privesc in the Docker container, and then you can mount the outside system to escape as one of the escapes you can do. So you'll see this in CTFs pretty often. So it says deploy the machine. Oh, okay, so we have to SSH. SSH is root at 10.10.44.142. Yes. TryHackMe at 123. All right. So we are root. Look, we elevated our privileges. We are root. And if we do ID, we can see stuff here. Okay, so we can run the Docker command. I know even with that, I think we can escape some things. We'll see. Complete me to progress the room. Let's do it. Container vulnerabilities. Let me zoom in so y'all can see it a little bit better. Before we begin, it's important to recap some of the things learned in the intro to containerization room. First, let's recall that containers are isolated and have minimal environments. The picture below depicts the environment of a container. So think about almost like a VM. In some ways, we have this isolation and virtualization going. We have our physical computer, right? That's like the hardware. Then we have our host operating system. And then on top of that, we have the Docker engine, almost like a virtual machine. But in the Docker engine, we have different containers that are isolated. That's what it's trying to highlight for us. So some important things to note. Just because you have access or a foothold to a container, it does not mean you have access to the host OS and associated files or other containers. Due to the minimal nature of containers, they have only the tools specified by the developer. You are unlikely to find fundamental tools such as netcat, wget, or even bash, and that is something I've noticed. This makes interacting with the container quite difficult for an attacker. So what sort of vulnerabilities can we expect to find in a Docker container? While Docker containers are designed to isolate applications from one another, they can still be vulnerable. For example, hard-coded passwords, we can do environment. I wonder if we see any here. Do I see any? Sometimes you'll see some passwords here. Not seeing any right there, but sometimes you'll see it. And if an attacker is able to gain access through a vulnerable web app, for example, they'll be able to find these credentials. You see an example of a web app containing hard-coded creds to a database server in the code snippet below. Right, so we have our database host name, our database name, username, and then our password. This, of course, isn't the only vuln that can be exploited in containers. The other potential attack vectors have been listed in the table below. So let's see what they are. Misconfigured containers. These will have privileges that are not necessary for the operation of the container. For example, a container running in privilege mode will have access to the host OS, removing the layers of isolation. Vulnerable images. There have been numerous incidents of popular Docker images being backdoored to perform malicious actions such as crypto mining. and network connectivity. A container that is not correctly networked can be exposed to the internet. For example, a database container for a web app should only be accessible to the web application container, not the internet. Additionally, containers can serve to become a method of lateral movement. Once an attacker has access to a container, they may be able to interact with other containers on the host that are not exposed to the network. All right, word, got it. Vulnerability number 1, privileged containers or capabilities. As a fundamental, let me see who's texting me real quick. Is this my kid's school? So they got school canceled again. Hold up. Oh my goodness, it's closed. Y'all, my kid's school has canceled school Monday of this week, Tuesday of this week, and now Friday due to snowstorms. What fun stuff. Anyways, let's keep going. These capabilities determine what permissions a Docker container has on the OS. Docker containers can run in 2 modes, user mode and privilege mode. And actually, if you go through hack tricks on Docker and containers, this is something that you will check. So in the diagram below, we can see 2 different modes in action and level of access each mode has. All right, so normal mode are these 2. So we have application environment Docker engine, application environment Docker engine, and look, privilege mode, we skip the Docker engine and we can hit the host. So if it's in privilege mode, we can escape and hit the host. So note how containers 1 and 2 are in user normal mode, whereas container 3 is running in privilege mode. Containers in user mode interact with the OS through the Docker engine. Privileged containers, however, do not do this. Instead, they bypass the Docker engine, directly communicate with the OS. So what does this mean for us? Well, if a container is running with privileged access to the OS, we can, oh my goodness, now here's the school calling me saying that they don't have school. They really want to get that message out. We can effectively execute commands as root on the host. We can use capabilities such as this, which I think I was trying to do on, gosh, what room was that? Maybe it was business, actually. I didn't live stream that one. That may have been when I was trying to do that. But we can use utilities such as that, which comes in that package to list the capabilities our container has. So let's do that. Cap sh print. So actually, all these capabilities shows us already as a privileged container, I believe, and these as well, I think. Some capabilities are interested in providing the terminal snippet below, right? So those are our ones that are be interesting, and I believe we have those. I can actually see some of them right there. So we could do that, and we could just like grep cap sys module. Like, do we have that? Yeah, we have that. So we could, I mean, grep for each one of those. So if we did like cap shown, does that work? Whoops. Oh no, I meant to, I'm thinking of in regex, that means or. You might have to just grep each one. Either way. Blah, blah. We're going to use the mount sys call is allowed by the caper's capabilities to mount the host control groups into the container, which this is one thing that I believe Hacktricks takes you through. The code snippet below is based upon, but modified version of the POC created by TryHackMe, which details the inner workings of this exploit well. Reckless Gizmo said, yeah, it's going to snow here on Monday too, hoping my job calls and says they aren't opening. Yeah, I work fully remote, so I don't get any snow days, but I get to work every day like right here, so it's worth it. We got, on Monday, was it like 8 inches of snow or 9 inches of snow? And then today they're saying 2 to 7 inches, but then we're going to have like 40-mile-per-hour wind tomorrow, so it'll be ground blizzard conditions. And it's like, I think the high on Saturday, is it Saturday? The high is negative like 12 degrees Fahrenheit, so very beautiful. Low cost of living because, you know, no one wants to live here. All right, so what is this doing? We're going to make a temp directory, and then we're going to mount, and I think that's what we're escaping. We're going to mount the C group, temp C group, make directory X, echo 1 to notify unreleased, get the host path. Yeah, I think it's 12. Let me check. I'll check on my other tab real quick. Okay, so here's our forecast. The high for Saturday is -2 and the low is -13. On Sunday, guys, get this, the high. So the warmest it's going to get on Sunday is negative 10 degrees Fahrenheit, and the low will be negative 16. When you add, oh, it's going to be windy too. So with the wind chill, it probably is going to feel like negative 25 to negative 35, I'm guessing. So yeah, very, very beautiful. The lowest there is 28. Gizmo, that's like a heat wave, bro. I'd be outside with my kids playing in the snow. I love the snow when it's actually like not freezing, because it is fun to hang out with my kids in the snow, but we can't go in the snow when it feels like negative 30 out. All right, anyways, looking at these different steps. And I'm guessing he's going to explain it. We're making it executable, and then we're running it. So explaining the vulnerability. We need to create a group to use the Linux kernel to write and execute our exploit. The kernel uses C groups to manage processes on the OS. Since we can manage C groups as root on the host, we'll mount this to temp/cgrp. So that's what we're doing in the first one. Got it. For our exploit to execute, we'll need to tell the kernel to run our code. By adding 1 to that, we're telling the kernel to execute something once a C group finishes. So we're just echoing 1 to that. I got it. We find out where the containers files are stored on the host and stored as a variable. And that's with our sed stuff right there. We then echo the location of the container's files into our exploit, and then ultimately to the release agent, which is what will be executed by the C group once it's released, and we already set that up. And then let's turn our exploit into a shell on the host. And that's what we're doing there. Execute a command to echo the host flag into a file named flag.txt in the container once exploit is executed, and make our exploit executable. We create a process and store that in there. When the process is released, the contents will be executed. Okay, I think it makes sense to me. Perform the exploit in this task on the target machine. What is the value of the flag that has now been added to the container? All right, well, I'm going to do this actually one by one so we can understand what's going on, and I'm going to try to type most of them except for that one. So we will echo, oh no, we need to make directory first, just so we understand what we're doing. So we're making a directory in a temp, and we're calling it C group, and then mount T, because we need to use this group, RDMA, C group, temp, C group, and. So if this all succeeds, make directory temp, C group, X. Okay, and if we ls temp, all right, that did it. And now we want to add our 1 to notify and release so it executes. Echo 1, and then we're going to put that to temp C group X notify on release. Okay. So let's work through this again. So number 1, we need to create a group to use the Linux kernel to write and execute our exploit. The kernel uses C groups to manage processes on the OS. Since we manage C groups as root on the host, we'll mount this at temp. Okay, so this, that we can call that whatever we want, technically. We're just making that directory. We're mounting it with C group because the Linux kernel uses C group to manage processes. You know, I'm going to go like default sec that says that was super confusing. Can you explain it more human? No, I'm not smart, but you know who is? Explain this so that I am not confused. All right. So according to ChatGPT, our first command creates a temporary directory named C group. I got that. And then we have this mount command, mounts a control group, which is what the C group is, got it. File system with the RDM option on the previously created directory, which I did that, right? Make directory X creates a subdirectory named X inside the C group directory. Yep, which we did right there. Set notification on release, writes the value 1 to the notify and release file in the C group directory, which that makes sense because by doing that, by adding 1, we're telling the kernel execute something once a C group finishes. So we don't know what something to execute yet, but we're just saying, hey, once a C group finishes, execute something, right? And this uses sed to extract the host path from the etc mtab file and stores it in the variable host path. Okay. That's probably the one that's most confusing to me. Oh, whoops. Okay, so this is just getting, so this is our Docker container we're in right now. And what this is doing is getting the path. If we go back up to this is getting the path on the computer operating system where our Docker container is at, I believe, is how we're doing that. So in that command, in essence, we're kind of escaping Docker already into the host operating system, seeing where Docker is at. Okay, got it. That makes sense. Set release agent. So the echo host path, and that's this. So when we do host path, that variable, it's actually using this whole thing. So it's going to be this slash, so diff slash exploit. And then we're going to send it to our release agent. Writes the path to the exploit script to the release agent file in the C group directory. Right, so this one right here, I will just copy. I guess I will just copy these. Oh. There we go. I forgot the T. And then 5, of course. 5, we're creating the exploit. So at this point in time, the exploit has not been created yet. But we're adding this to the exploit, right here, like right on. Why are we putting the exploit right here? Maybe it'll make sense. We're just echoing that to exploit. Okay. And then, oh, I see. So we're putting all these in that exploit. So then all we're doing here is, of course, we're actually executing this on the host operating system, this cat command. So we're saying on the host, escape the Docker container, and on the host, what I want you to do is execute, get like cat flag.txt, and then put it in my host path right here, diff slash flag.txt. So then it's just available on the operating system, right? Oh, I'm already there. I don't know what I'm doing, but if I do, there's our exploit. This will put it in the exploit folder, I think, once it runs. Then we're changing the mod. All right, let's go back. Creates a shell script named exploit. Yep, I got that. Appends a command to the exploit script, which reads the content and writes it to a file named flag.txt in the host path. Now, could I also just like get a shell would be the question. I'd assume I could. We're turning this into a shell, but we could probably get a reverse shell. Sets execute permissions, which we did, and then execute the exploit. So sh-c to run a command, echo this, execute a shell command that writes a process ID to the C group's procs in the C group directory. Yo, that is confusing though, for real. Not something I would like just like sit down and figure out on my own. Oh shoot, did I do this wrong? I did forget a T in exploit. Do I have to redo this? All right, let me just, we already did that. We already did that. Did that. Oh, look, I forgot it again there. Come on, copy the right thing. apparently just suck at freaking copying and pasting. Look at that. Oh my goodness. I can't do it. That time it worked. Wow. That's our first flag. Can I want to play around with this a little bit though. What's the hint? Yeah, okay. I know that. If we go back up here. So we've already done that. I don't need to do that again. I don't need to do that again. I don't need to do that again. So that turns into a shell. Okay, that's fine. What if I do something like... And we do like a... Yeah, this is the new room on TryHackMe. You got it. Over on YouTube. What up, Tony? I am in the good old state of South Dakota, my friend. Where nobody lives because you'll die in the cold. Can I do this and get a shell? Taking it a step further. Will it work? I have no idea. Okay. I don't think I need to do that again. It's already executable. I think I just need to do this now. Nope. Okay, that doesn't work. Oh yeah, Wild West Hacking Fest is technically in South Dakota, but they're on a different side of South Dakota than me. So even for me to go there, it's like a 9-hour drive. So they're not like near me. I'm in the part of South Dakota where nobody lives. It's just cows. I mean, honestly, that's most of South Dakota, but they're on the cool side of South Dakota. I wonder why reverse shell doesn't work. If we can get to execute commands on the host, one would think that would work. Oh well, let's just keep going. Unit Sockets 101, one size fits all. When mentioning sockets, you would likely think of sockets in networking. Well, the concept here is almost the same. Sockets are used to move data between two places. Unix sockets use the file system to transfer data rather than networking interfaces. This is known as inter-process communication, or IPC, and is essential in operating systems because being able to send data between processes is extremely important. Unix sockets are substantially quicker at transferring data than TCP/IP sockets. This is why database technologies such as Redis boast such outstanding performance. Unix sockets also use file system permissions. This is important to remember for the next heading. So how does Docker use sockets? When interacting with the Docker engine, running commands such as docker run, this will be done using a socket. Usually this is done using a Unix socket unless you execute the commands to a remote Docker host. Recall that Unix sockets use file system permissions. This is why you must be a member of the Docker group or root to run Docker commands, as you will need the permissions to access the socket owned by Docker. And we are. Well, I'm just root, so we're not semantic yet. He's on the actual host operating system. So finding the Docker socket, docket socket sounds cooler though. Docker socket. Remember, containers interact with the host OS using the Docker engine and therefore have access to the Docker socket. This socket, named docker.sock, will be mounted in the container. The location this varies by OS the container is running, so you would want to find it. However, in this example, the container runs Ubuntu 18.04, meaning the Docker sock is located in var run. This location can vary based on OS and can even be manually set by the developer at runtime of the container. So lsla var run grep, get some socks. Oh, wait, no, he's on the host OS. Am I supposed to be on the host OS? I don't think so, right? He's just showing us on the host OS. Exploiting the Docker socket in a container. First, let's confirm we can execute Docker commands. You will either need to be root on the container or have the Docker group permissions, blah, blah, blah. So let's break it down. We will use Docker to create a new container. Oh, I've done this before. Yeah. And mount the host file system into this new container. Then we are going to access the new container and look at the host file system. There's at least a few machines that this is the privs path. Yep, I've done this a handful of times, actually. Our final command will look like this. All right, docker run v mount alpine, and this all depends on what the Docker image is. Shroot mount sh, which does the following. We will need to upload a Docker image. For this room, I have provided this on the VM. It is called Alpine. The Alpine distribution is not a necessity, and it's not. The first time I did this, I was confused. It was like, yo, Alpine's not here, but you don't need Alpine. It can be different things. But it's extremely lightweight and will blend in a lot better. To avoid detection, it is best to use an image that is already present in the system. Otherwise, you'll have to upload this yourself. We will use docker run to start the new container and mount the host file system, which is docker run, right? We're mounting the host file system to mount in our Docker container. Hi, kitty. Are you licking your paw at all, kitty? You doing good? Doing good? Okay, thumbs up. You don't have thumbs. Haha. We will tell the container to run interactively so that we can execute the commands in the new container, right? IT interactive. Now we will use the already provided Alpine image. We will use shroot to change the root directory of the container to mount, where we are mounting the files from the host OS. So change root to mount. 1 second, guys. I forgot what my cat's doing. Come here, kitty. Here's my cat, everyone. Oh, geez, he's trying to jump. All right, never mind. He doesn't want to be allowed out. Bye, cat. Don't hurt yourself. Don't lick your arm. Okay. Distracting myself. Where we are mounting the files. All right. Now we will tell the container to run sh to gain a shell and execute commands in the container. Yep, all that makes sense. You may need to Control-C to cancel the exploit once or twice for it to work, but as you can see below, we have successfully mounted the host OS into the new Alpine container. So let's do this. I'm going to type it out. I think it's good to type it so you understand it better. So docker run, I think we have that figured out. V, we want to mount. So this is the host. So not the Docker, this is the host. So we're escaping into the host, and we want to mount the host root directory, and we want to mount it though to our mount directory. This is in our container. RMIT in order to make it interactive session. Alpine is just the image, but it could be different images. Shroot mount sh to get a shell. What you doing, cat? Trying to drink water. All right. Sorry, I really do have to watch my cat. So if I cd over to mount, or am I in the host operating system now? Oh no, I escaped. I'm in the host operating system now. You see that? We have Semantic, TryHackMe, Ubuntu. So after executing the command, we should see that we've been placed into a new container. Remember, we mounted the host file system to mount and then use shroot to make the container's mount become the root directory. So let's see the content by doing ls. I already did that. All right, name the directory path which contains the var docker sock file in the container, var run. Perform this exploit. What is the value of the flag located at root flag? Now from here, can I get a shell? Since I'm running these commands on the root system, right? Oh, okay, it doesn't have that. Well, let's just try my bash reverse cell. Oh, maybe that was my issue. Well, no, that should still work, I think. Oh, wait, that's not what I want to do. Oh, gosh, and my terminal is obviously not interactive. Let's try this one more time. I just want this. I don't want to echo it anywhere. Oh, okay, once again, if I could just get my syntax right. Oh no, that's not going to work. What if I echo? Okay, change mod. It's like my nano. Oh, so that's not going to work at all. Why does that not work? What does that even mean? Bad FD. Now I'm just curious. And hopefully what I'm showing you guys, when you do rooms like TryHackMe, it's easy just to read it and do it, but like play around with the room. The goal isn't to complete it super fast. Why do I get... Thanks for giving me a reverse shell. Nope. That doesn't do it either. Let's try a Python reverse shell. What is this DuckDuckGo search crap, yo? Here's what I'm looking for. I know some of y'all just use that one website. Rev Shell or something. I don't. Not because I have anything against it. I probably should. Why do we not have word wrap on? Alright, let's see if I can get this to work. Now if we copy all of this, it's my last attempt. Ah, I got it. Boom, I have my reverse shell finally. That's what I wanted this whole time. Now, if so I'm in roots file, right? If I make a directory called SSH, okay, CD SSH, we have authorized keys. We can actually echo home parrot Do I not have it? Let's try that again. All right, now I have my key. And for persistence, we could echo that into authorized keys. And now I should be able to SSH as root into the actual host machine. Oh, does it not have key authentication enabled? It should work. Maybe that doesn't work. Oh well, at least I have a reverse shell. Authorized keys. Am I not in that directory anymore? No. Oh, maybe we have some weird buggy stuff here. What if I replace it completely? Echo. It's not what I... What are you doing? Oh, no. Shoot. Frick. I know I'm totally seem like I'm wasting my time, which I probably am, but this is more fun. All right. Now I have my reverse shell. All right, now I'm just going to do my command out here, and then I'll paste it in since it doesn't like the way I'm doing it. So it's going to be echo this into authorized keys like that. Now, did it work? Okay, so my key is the only one now in authorized keys. Oh, you know what? They may not allow root login. That might actually be the issue. So actually, if I go cd home ls make directory ssh cd ssh, and then same command here. Let's see if we can ssh as him. Okay. I don't know if I spelled that right. Simnatic. No, okay, so it doesn't allow key-based authentication. You need password authentication for SSH. Oh, well, I have my reverse shell. Let's keep going. We'll go back over to here. I guess we can do it from here. We can do it from anywhere. I just wanted to see if I can get a reverse shell through this way, and I can. Remote code execution via exposed Docker daemon. Recall how Docker uses sockets to communicate between the host OS and containers in the previous task. Docker can also use TCP sockets to achieve this. Docker can be remotely administered, for example, using management tools. Looking for my cat. Okay, I can see him. He's doing good. Using management tools such as Portainer or Jenkins to deploy containers to test their code. Yay, automation. The vulnerability. The Docker engine will listen on a port when configured to be run remotely. The Docker engine is easy to make remotely accessible, but difficult to do securely. The vulnerability here is Docker is remotely accessible and allows anyone to execute commands. First, we will need to enumerate. Enumerating. Finding out if a device has Docker remotely accessible. By default, the engine will run on port 2375. We can confirm this by performing an mmap scan against our target from our attack box, which I guess I can get out of this. I want to get back into the container. We'll make it legit. All right. So we'll do our mmap scan and we'll check that port. So we'll do mmap-p 2375-a because I want to see what it all says. 10.10.44142/v for verbose mode. And we'll just let it run. Shouldn't take too long. But you can see it's going to be open. And yeah, here we get a bunch of information right here. So we have Docker, we have the Docker version, we see that it's listening. And so we'll make note of that. If we ever see this running, hey, let's think about this possible exploit. So it's open. We're going to use curl to start interacting with the exposed Docker daemon. So let's give that a shot. So we're just going to get the version first, which I already have the version. But we can confirm, hey, we're actually able to interact with it. And I can probably JQ that to make it look a little bit nicer. Oh, no, that doesn't work? Okay, usually that formats it a little better. Oh, well. Executing Docker commands on the target. For this, we'll need to tell our version of Docker to send the command to our target, not our own machine. We can add the H switch to our target. To test if we can run commands, we'll list the containers on the target. So is this from our attack machine then? Or is this from our container here? I think it's actually from our container. Yeah, it's from our container. I got it. Not from our attack machine. Would it work from our attack machine? I don't think so. Apparently, paired's still broken. Oh well. So Docker command, what do you want? Oh, we just asked what processes are running, right? So can I do like, no. Oh, it has to be a Docker command. Gotcha. Yeah, so I can list images, for example. So these are all the images on this remote computer. Docker test, Vuln SSH, Docker, Vuln SSH, Alpine, Ubuntu. And that's what I do with that images command. So can I do... There's probably a few different things I could do. Let's keep... I'm getting ahead of myself. What now? Now that we confirm that we can execute Docker commands on our target, we can do all sorts of things. Exactly what I was saying. For example, start containers, stop containers, delete them, or export the contents of the containers for us to analyze further. It is worth recalling the commands covered in Intro to Docker. However, I included some commands that you may wish to explore. So we can do network ls. Right? We can do images, which I already did. We can execute commands on a container. We'd have to say the commands, or run a container. So if we do like images, I do, so Docker, oh, okay. I did the syntax wrong there. Is it Ubuntu and then bin/sh? Maybe I need to use the image ID. Or is it, jeez, is it Ubuntu? Maybe it's not running? 2375 PS. Is just Docker test running then? Yeah, that must be all it is. The other ones aren't running, so I can't. What I was trying to do is drop into like an interactive shell on the Ubuntu container, but it's not running. The only one that's actually running with PS is this Docker test one. What port number by default does the Docker engine use? Well, we've been using it, 2375. All right, abusing namespace. What are namespaces? Namespaces segregate system resources such as processes, files, and memory away from other namespaces. Every process running on Linux will be assigned two things, a namespace and a PID, or a process identifier. Namespaces are how containerization is achieved. Processes can only see the process in the same namespace. Take Docker, for example. Every new container will run as a new namespace, although the container may run multiple applications or processes. Let's prove the concept of containerization by comparing the number of processes on the host OS in comparison to the Docker container that the host is running. Well, I don't have my shell on the host OS anymore. We could go back and get one, but I'm just going to take your word for it. So this is an Apache 2 web server, right? So this is the host OS. On the first column on the left, we can see the user process is running as, including the process number, right? The PID right there. Additionally, notice that the column on the very right has the command or application that started the process, such as Firefox or GNOME Terminal. It's important to note here that multiple applications or processes are running, specifically 320. Generally speaking, a Docker container will have very few processes running, right? So, yeah, quite a few less than 320 anyways. Determining if we're in a container via processes. We'll list the process running our Docker daemon using PSAUX, which we did, and we can even see some of the stuff like container and whatnot. It's important to note that we only have 6 processes running in this example. We have more in ours. The difference in the number of processes is usually a great indicator that we're in a container. Additionally, the first process in the snippet below has a PID of 1. This is the first process that is running. PID in it is the ancestor parent for all future processes that are started. Right there. And all processes that are stopped too. Comparatively, we can see that only 5 processes are running, a good indicator that we're in a container. However, as we'll come to discover shortly, this is not 100% indicative. There are cases where, ironically, you want the container to be able to interact directly with the host. Okay? How can we abuse namespaces? Well, recall C groups or control groups in a previous vulnerability. That was the first one that we were doing. We are going to be using these in another method of exploitation. This attack, I want to understand this better. Execute a Docker. All right, the scenario you mentioned involves security vulnerable exploit where an attacker attempts to escape and interact. So it allows allocation of resources among processes, providing isolation and limiting the resource available to a process or group. So we can mount C groups. So that's just showing the script that we did. Well, that's not actually very helpful. Thanks, ChatGPT. But we're going to use that same control group to abuse namespaces. You might see this in cases where the container relies on a process running or needs to plug into the host, such as the use of debugging tools. In these situations, you can expect to see the host processes in the container when listing them via PSAUX. Which maybe that's what I'm seeing here. That's why I have so many, maybe. Yeah, Python. Do we have Python in the container? Oh, we do. You usually don't have that in containers. The exploit. For this vulnerability, we'll be using incenter, namespace enter. This command allows us to execute or start processes and place them within the same namespace as another process. Okay. In this case, we'll be abusing the fact that the container can see the sbin init process on the host. So we can see that on the host. So we are able to see host processes, meaning that we can launch new commands such as a bash shell on the host, which I already did a little bit on my own. So use the following exploit. Incenter, so namespace enter, target 1. So we're targeting the PID of 1, which is the init process. And then we're doing mount, UTS, IPC communication, net, and bin/bash. Okay. So target, I got that. Mount. This is where we provide the mount namespace of the process that we are targeting. Jeez, this Docker stuff is confusing, I think. Maybe y'all are smarter than me. The UTS switch allows us to share the same UTS namespace as the target process, meaning the same host name is used. Okay, gotcha. IPC means we enter, so we already talked about inter-process communication. Means memory can be shared. That's how the Docker container communicates. The net switch means that we enter the network namespace, meaning that we can interact with network-related features of the system. For example, the network interfaces. We can use this to open up a new connection, such as a stable reverse shell on the host. As we are targeting the sbin init process number 1, although it's a symbolic link to lib systemd for backwards compatibility, we are using the namespace and permissions of the systemd daemon for our new process, the shell. Okay. Since we're targeting that, we're using the namespace. Okay. Here's where the process will be executed in this privileged namespace. Let's say your shell. This will execute the same namespace and therefore privileges of the kernel. Wow. Okay. Explain like I'm 5. Okay. All right, let's break this down in a simpler way. Imagine your computer is like a little town, and each program you run is like a house in that town. Now, there's a special house in the town, the one with the ID number of 1. This house is like the manager of the whole town, bro. It's very powerful. Now, you want to do some special tricks and get some superpowers. Here's how you do it. Go into the special house. You use a magic number called NS enter target 1. It's like saying, hey, let's do something in the manager's house. We bring stuff from the manager's house. You want to play some cool toys from the manager's house, so you use a mount to grab the special container of toys or the namespace from the manager's house. All right. Sharing the same name. You also want to have the same name as the manager. It's like having the same last name as someone in your family. So you use UTS to share the same name. Host name. Okay, got it. Sharing memories. I like it. You want to share memories with the manager. This is like remembering things together. So you use IPC to share the same memory space. Got it. Playing with networks, you want to play with the cool gadgets related to the town's network, so you use --net to enter the network area and mess around with things like internet connections. And using the manager's powers, since you're doing all this in the manager's house, process ID 1, often linked to that, you get to use the manager's superpowers. It's like having access to the big boss's abilities, doing your trick. Now you decide what special trick you want to do in the manager's house. You use bin bash or simply sh to open any door, play around in the same powerful space. Honestly, that's actually really helpful. I understand it a little better now. And look, I'm root at THM. You see it changed there? That's really cool. And it's a nice stable shell. Bin bash. Cool. How do we know we can do that? Okay, so this is the key. If our container can interact with the host processes, then we can abuse the namespace. Is that kind of the key? I think so. Got a cold. Getting a cold. Using the command line of the container to run commands on the host. Yep, which we can do that. If I could spell. Ours is just THM. Perform the exploit in this task. What's the flag located there? So CD, TryHackMe, cat flag.txt. Your space, my space. Conclusion. Phew, that was fun. In today's room, we learned about some possible misconfigurations with Docker containers, how to discover these and ultimately exploit them. Now, you might be wondering why it is the case that containers might run with privs that effectively bypass the security mechanisms Docker introduces. Well, while it isn't a recommended practice, there are use cases where containers do need this level of interaction. For example, running Docker within Docker, or specific applications such as firewalls that need to interact with the host IP tables, or perhaps attached devices. Ultimately, there's also an element of taking the quick and easy route out when trying to figure out what permissions to assign a container. Docker, especially in recent times, does a great job of hardening. For example, you can give a container-specific capabilities on an allow list basis. However, it isn't too far-fetched to think that people would just give more than necessary capabilities to get something to work without realizing the wider consequences. We will come on to how you can prevent these misconfigurations and vulnerabilities in the next room. Container hardening coming soon. Finish the room. Boom, we have completed the room. You are my only friend, so I'm sharing it with you. We have completed Container Vulnerabilities, the latest room on TryHackMe. Shout out to Simnatic, the room creator. I know sometimes he joins us over on chat. Thank you for the room on what I think is a very confusing topic, but learn some good stuff in it. Thank you for that. For those of you on stream, I'm not going to sign off just yet, but if you're watching on YouTube, this is the end of this video, the walkthrough of the Container Vulnerabilities room. So if you're on YouTube, thank you for taking the time working through this room with me. Hope you enjoyed it, and I will see you in the next one.